All right, so we just finished talking about the properties of the functions, and we found when we investigated the quartic, we're starting to get repetition in the general shape. So there's actually, you can't tell the difference between this being a quadratic and this being a quartic when you're zoomed in looking at one particular point. So that leads us to the actual concept of multiplicity. So what is multiplicity? Multiplicity is a concept that relates the root of a function with the degree of the factor, and in brackets, talking about that root. So it's a connection between the degree of that factor and the root itself on the graph. So when we're looking at this in terms of being able to diagnose or being able to come up with graphs, we know that we are looking for, in factored form, and that's going to be the key here. Whenever you're asked to sketch a graph or come up with the equation, you're going to give me the answer in factored form. I don't want you to waste your time with distributive law at this point. So factored form, the function's going to look like this. So there's going to be some coefficient out front, a, multiplying x minus m to the exponent n, x minus n to the exponent p, and so on and so forth until you have your entire function. And the general form is when it's in non-factored form. So it would be some ax to the n plus bx to the n minus 1 plus cx to the n minus 2, and so on and so forth. Okay? This form, okay, not good for graphing by hand, and you don't have to graph something like this by hand. All right, and this is the form we want. We want factored form. All right, so let's talk about, draw some conclusions here. So when we're talking about degree, we're talking about first degree, second degree, third degree, fourth degree, and I'll take it as far as fifth degree for argument's sake. So what's my example? I'm going to use the same example all the way through. So x minus 2. This would be x minus 2 squared. So we'll put a 1 up there even though it's not necessary, it won't appear. X minus 2 cubed. X minus, let's stick with x minus 2 all the way down here. So the fourth, and x minus 2 to the fifth. So we're looking at the x-intercept. Where is the x-intercept? The x-intercept occurs where this bracket is equal to 0. So all the way down, the x-intercept is at the point 2, 0. Okay? You have to have, x would have to be a positive 2. The x-intercept occurs when the y value is 0. So for each point, okay, it's going to be 2, 0. So what's the characteristic? What would the graph look like? So all we're doing is the x-axis. You don't create a y-axis here, and we're looking at the value 2. So for everyone here, we're just looking at positive 2, or where the x-intercept occurs, all right? So what does the graph look like at x minus 2? If it has a degree 1, it's going to be linear. It's going to be a line. So it's just a little segment. So we're zoomed right in. So it's going to look linear. What happens if it's squared? Well, because it's a positive, we're going to assume a positive, it's going to take on a parabolic shape at that root. All right. What happens if it's cubed? If it's cubed, we get that S pattern, that S curve. Try to draw my best S curve through 2. What happens if we get to a fourth order? Well, in that previous example, I said you stop being able to determine, is it a quartic or is it a parabola? So when you get to that, back to our note here, it's going to take on the parabolic shape again. So it's going to look the exact same as a quadratic. So we don't go any further. We don't worry about anything past a degree 3. Similarly, with a degree 5, if I was to draw a 5th degree function for you, it'll look like an S-curve again. So these two properties, they repeat, or the shapes repeat at x-axis. So really, all we really need to be able to do, or all we can really generalize, is that at a root, it's either going to be a degree 1, where it's linear, degree 2, where it's a parabola or quadratic, or a degree 3. All right? If it turns out to be a degree 5, we really can't do it unless we have the right technology to go ahead and figure that out. All right? So we can conclude that functions with odd degrees, and we'll just do the exit in opposite directions. And even degrees exit in the same direction. And hopefully you came to that conclusion yourself, or at least when you look back at the investigation you completed, that you agree with that. All right. Before I get to this example, if you have some space, maybe on the back of a piece of paper, I want to do another example before I start coming up with the equations. So I'm going to add a page in here, and if you can draw a rough XY axis, all right. Don't even need to worry about the ruler for this example since I didn't have it set out for you. And just put the increments on. 1, 2, 3, 4, 5. 2, 3, 4, 5. 3, 4, 5. 4. Okay, so what the instruction here is going to be is graph. Graph the following. I'm going to do one example, and if you're still not sure on this, when you get to the homework, you can come and ask me, how do you clean this up? So all we can really do, and it really shouldn't be graph, it should be sketch, but I'm not going to change it and make you cross it out now. Let's do 0.5 x plus 4 squared, x plus 1 cubed, x minus 2, and then x minus 4, and we'll make it squared. All right, so I'm going to move this down just the way I put my grid. All right, down here somewhere, shrink it a little bit. Okay, so what is the degree of this function? All right, let's talk about a couple things first. What is the degree? The degree is the sum of the exponents on each root. So on the x plus 4 there's a 2, plus on the x plus 1 there's a 3, on the x minus 2 there's a 1, and on the x minus 4 there's a 2. So the degree of this function is 5, 6, 7, 8. All right, so that means that it exits and enters in same direction. I know A is positive, so A equals 0.5, so it opens up. So I start filling in the information as we go. So what are my roots here? So from above, the roots, they're located at, so x plus 4, so the first root is going to be at negative 4. The second root is going to be at negative 1. The third root will be at positive 2. And the last root will be at positive 4. So at those locations, I'm going to sketch my graph. So over at negative 4, so negative 1, 2, 3, 4. So I'm going to put a dot there so you can see where I'm looking. I know that it's a positive graph, so it opens up. So that means that I'm going to be coming from up here somewhere. All right? So that being said, what's happening at x plus 4? It is squared. So that means the shape at that point is going to be parabolic. So I have two options. It's going to either look like this, or it's going to look like this. Now, I already said it's going to be coming from up here somewhere, so it has to be the top option. So I'm just going to get rid of that for a sec. Okay, so I know that it's going to be like this. So I'm just going to put a little shape in there. What's happening at the x plus 1? So that's this point right here. It's an S curve. I have to connect this part of my graph with what I'm going to draw here. So that means my S curve has to be drawn so that my tail is up in the air there. All right, so maybe I didn't draw it quite the best here. Let's see if I can do a little bit better job. All right, that's the S curve. Now at positive 2, it's got to be linear. It's got to be a line. And I know that I've got to connect this point with it. So I got to be below the x-axis. So at positive 2, it's going to be a little line segment, looks like that. And at positive 4, 1, 2, 3, 4, we're back to a parabolic shape. And now I'm going to be above the x-axis. So my parabola has to be looking like that. So now I just have to connect all my shapes together. And we end up with a graph that looks like this. Okay, it's not going to be perfect. If I put this equation into a graphing calculator, it's not going to look exactly like that. But I'm not worried about it being exactly looking like it. I want you to be able to determine the general shape. And if you're to use the graphing calculator, you would find it's going to be parabolic at -4. There's going to be an S curve at -1. It's going to be linear here, and it's going to be parabolic here. So the graphing calculator at those 4 points, that's what it would look like. It's going to be probably out of scale. This value is probably way up somewhere, and the minimum's likely down, and so on and so forth. But anyway, it gives you a general shape. All right, that's what it's going to look like in general. Okay, so I'll finish up with the other examples that you do have in front of you. You're going to have to do some sketching in the homework. I don't know why I didn't have a slide in for it, so I do apologize. So when you get to the sketching, if you want me to help you with the first 1 or 2, I'll definitely help you out with that. So we'll finish up in that next video.